closed depending on whether or not you tell it to be open or closed. So that's the hardware. Pretty simple. And then you can jam everything in some sort of enclosure like I have here. I use these little 3M mounting squares to jam it in the bottom so it doesn't move around. And then if you have a drill, or in my case you're lazy and you have a pair of cutting pliers, you can notch out the sides as elegantly as I've done here. As you can see, it's very, very smooth, not sharp at all. And then I've got holes on the bottom on either side just for the USB cord to fit through, the USB plug on this side. So just, line them up. I'm not very good at stuff like that, so mine looks like crap.
What's the maximum number of channels you can serve with?
Until my software crashes. Basically, I haven't found an upper limit yet, but people have hooked up.
So 4 or 5 USB hub and
basically, yeah. Now there are other ways to do this. Fidget makes 2 boards, one of which is a 0-16-16, which has 16 digital outputs. The problem is it can't handle the current that would be required to hook up an extension cord directly to it. It can handle about 2 to 4, they go up to 5 volts of DC current, so if you're going to jam 110, 120 volts of household current through it, you're going to fry it pretty quickly. But what you can do is if you have a little more knowledge about relays and whatnot, you can buy solid state relays or mechanical relays and hook those up to the digital outs of those boards, then wire the extension cords into those. So it's a secondary step. I priced it all out. By the time I got done, it was pretty much the same price to buy the fidget board at $57 than it was to buy the 16 board and buy relays and everything else required, so I went this route because I'm lazy. So that's the final bit, 2 boards, a whole bunch of extension cords. I call it the octopus. And on either side now you've got 4 female extension cords and 1 male. And this one male drives these 4, and the other male drives the other 4. So you can now hook this up, hopefully, through the USB, assuming I line up the holes good enough. Good noises. I like that. USB. Flip that over. All right. So that's half the equation. You've got the hardware, and I need something to actually turn the relays on and off in time to music. So, before let's talk about amperages real quick. The relays for this board are rated at 10 amps for 250 volts. So it's about a little over 20 amps for 110 volts. Your average strand of mini lights, which are these, I'll find these at Target or wherever else you buy light bulbs, draw about 0.3 amps. If you have a strand of regular bulbs that have like the actual light bulbs, not these little mini things, they draw about 1 to 2 amps per string. And most of your household circuits indoor are rated for about 15 to 20 amps, depending on your wiring and whatever else. Usually outdoor circuits are a little higher, so if you're running an outdoor show, you don't have to worry too much about this. But in all, just don't draw more than 15 to 20 amps per circuit in your home, and it's going to go for everything that's on that circuit. So if you have one outlet in your living room, it's whatever is on that circuit. It's not just the outlet, but it's the entire circuit. However many outlets are on that circuit. I've never had a problem. I've never heard of anyone else having a problem. I think you need a whole lot of lights in order to even get that close. But just so you know. So for the software, we're just going to create a simple WinForms.net app that's going to have a grid interface. And the grid's going to be divided up in seconds, and then each one of those seconds is going to be divided up into subsections. We're going to do 1 square about every 50 milliseconds, because that seems to be about as fast as the fidgets can switch on and off, which seems to be fast enough for doing a decent show. So the software will allow you to record beats, so you can tap out which channel you want to be turned on and time to the music. We'll also do that with MIDI files, where it'll actually read the MIDI data in and throw the data into the grid, so you can kind of get a bass show up and running pretty quickly, and then tweak it from there. The software will play WAV files, or MP3 files, or MIDI files. Those would be the 3 basic formats. One of the things I added recently was playlist functionality, so you can create 5 or 6 different songs and create a playlist of them and just have them loop in order back to the start. And of course, it needs to play back everything that we've written, saved, and persisted. So let's look at Late Sequencer, which is the name of the application. I am in a public location apparently. I think I need to change so you can all see it. Good. So this is it's a pretty simple project. A handful of classes, 3 or 4 forms. Let's go straight to the main form. And there's got toolbar, menu bar, the gray areas where the grid shows up. Nothing too spectacular here. What I'll show you is how the grid is drawn, because I wound up having to do kind of a bizarre hack in order to get this to work. So we're basically going to create these files called sequence files, which is just an XML file and a schema that I created that happens to work for what I'm needing to do here. So in order to create this grid, we're going to get a length of the music in seconds. If it's an MP3 or a WAV file, you have to know what it is in advance. So you can just load it up in Media Player and look at whatever the final time is, and that'll work. The MIDI files, I can calculate that pretty easily, so that will be handled automatically. Now, actually, let me run the app so you can see it first, because otherwise you're not going to understand what the hell I'm talking about. So let's create a new sequence. I'm going to load up the music file. I've got some Chris was using here. We'll use the same MP3 that I was using before. We'll just make it for a minute for now, and you can provide a title and an artist. So. Now in this grid on the bottom here is a list of every fidget device that it finds connected to the system, and it doesn't discriminate about which type it is, if it's a 004 or a 01616 or an 888, it doesn't care. It's up to you to properly hook it up to the relays and whatever else. So I've got 2 boards, and each fidget board is given a serial number, and that's how we can communicate with each one individually. So you'll see that there's 4 entries here with 9517, 4 entries with 77776, and we need to map the output ports on the fidgets to whatever channel is going to show up in our grid. So it just picks channel 1 through 8 and assigns it output ports of 0123 and 0123 for each board. And you can edit these as you wish. So if if your string that happens to be in the window is on input port 4 or on output port 2, you can go ahead and type that in and change it so you don't have to rewire your house. You can just change it in software. So once we do that, it's going to draw a grid